Now that we are well versed in adding and subtracting our integers, we can start solving one-step equations relatively easily. I understand that a lot of you are going to know the value of x without showing any work, but we're going to practice steps to show our work with these simple equations so you can trust the process when we get to more complex equations. So here we have x plus 5 equals 9. We want to create a 0 here. We want to use our additive inverse. The way we make a 0 with a positive 5 is by subtracting 5 or adding negative 5. We have to do it to both sides because this equal sign tells us that whatever happens over here also needs to happen over here. It won't be equal otherwise. What we have left here is x plus 0 equals 4. That's how we can say x equals 4. Here we're subtracting 9 because we want to make a 0 here. The statement is x plus 9 equals negative 4. We're going to take 9 away, create our 0. And now we have x plus 0. We have negative 4, take away 9. That's like negative 4 plus negative 9. So that's going to give us a negative 13. X equals negative 13. Whenever we solve one of these equations, especially the simple ones, we want to quickly go back and mentally make sure it works. When we found out x equals 4, we want to say, is 4 plus 5 9? Yes, it is. When we find x equals negative 13, we say, is negative 13 plus 9 negative 4? Yes, it is. We did it correctly. Let's look at these subtractive expressions over here. If I'm taking 3 away to make 7, I got to add that 3 back to create a 0 on both sides. X minus 0 equals 10. So we know x equals 10. Is 10 minus 3 7? Yes, it is. Here we have x minus 7 equals negative 10. We add 7 here to make a 0, add 7 here to keep things equal. X minus 0 equals negative 10 plus 7. Negative 10 has the greatest absolute value. I'm going to have a negative 3. That's the difference. X equals negative 3. And negative 3 minus 7 equals negative 10. Let's look at a few more examples of how we can solve equations in one step using addition and subtraction. So these examples are a little different from the last examples because the number, the numerical term, is coming before the variable. This can be a little tricky for people sometimes. We just want to come back to our same idea of creating a 0. I'll write this up here really quickly and remind us from a previous video that we have inverse operations of addition and subtraction. And what these do for us is they create the additive identity. Additive identity, which is just a fancy way of saying 0. If you add or subtract 0 from any number, that number retains its identity. It stays the same. So we're looking for zeros here. Negative 3 plus x. How do I create a 0? Well, if I have a negative 3, I need to come 3 in the positive direction, add 3 to both sides of the equal sign, and 0 plus x equals 8, or x equals 8. And negative 3 plus 8 does equal positive 5. Here we have 15 plus y equals 9. Many people will add 15 to both sides here, but we have to pay attention to the sign. This is a positive 15. To make this a 0, we have to subtract 15 from both sides. Subtract 15. So now we have 0 plus y equals 9 minus 15, or 9 plus negative 15. It's going to be negative 6. Y equals negative 6. And 15 plus negative 6 is 9. Coming over here, we have a positive 13 plus x equals 17. To make a 0, we have to subtract that 13 from both sides. And we have 0 plus x equals positive 4. X equals 4. 13 plus 4 equals 17. Here we have a negative 19. A negative 19. So to make a 0, we add 19. Add 19 on the other side of the equal sign. So we have 0 plus x equals 23. X equals 23. And then we ask ourselves, is negative 19 plus 23 positive 4? Yes, it is.